Well, hello, my honors algebra students. I hope life is going good. Now, we're working with Trig on the Cartesian coordinate system. Hopefully, you're starting to memorize this sine, cosine, tangent, cosecant, secant, and cotangent in terms of x, y, and r on the Cartesian coordinates plane. We'll be using that a little bit today, actually. And I hope you have this down or close to it because we'll be using that not today, but probably tomorrow and Friday. Duh. So notice, oh wow, tomorrow's a football draft. I'm hoping the Lions draft a football because that might help them. But anyways, today we're continuing with the Cartesian coordinate system. What we're going to do is take a ray. Now that's one side of an angle. And we're going to place the vertex of the angle at the origin and lay one of the rays along the positive x-axis. That's the starting side. We're going to call that the initial side. And that's where everything initiates, where it starts. Then the other ray is put somewhere out on the Cartesian coordinate system. And we're going to call that the terminal side. That's where we stop it. And we can measure it different ways. You could either go from the initial side, they used to call it counterclockwise, but most of you don't even know what a clock is anymore. That's positive measure. And if we start at the initial side and go clockwise, ooh, that looks like a Pac-Man. That's the negative measure. So, if I told you that this, and I'm just making this up, is 120 degrees, then another angle that goes with that would be negative 240. Now, we're going to talk more about that tomorrow. Today, I want to focus on something called quadrantal angles. And a quadrantal angle is where the terminal side lies on an axis. Terminal side is on an axis. So if the terminal side, now the initial is always origin along the positive, always. So if the terminal is on an axis, what angle multiplication would it have to be? What would the degree of the angles have to be a multiple of always? Think. Well, if it's here, if it's here, if it's here, that means it's always a multiple of 90 degrees. Now, we can find the trig functions of quadrantal angles. Oops, I can't even spell functions anymore. So, let's say I ask, what is the trig function? Let's say a sine of 90 degrees. That's a quadrantal angle because here's the initial and then the terminal lies here. Well, if we can pick a point on the terminal side, we can find the trig functions. Now, if it's not on a quadrantal angle, if it's not a quadrantal angle or a multiple of 90, you can't do this. But if it is, we can. So, you just pick a point. Now, they recommend, and there's a lot of reasons, you always pick the point 1 unit from the origin. So, one ordered pair is 1 unit straight up. Well, that would be 0, 1. So sine 90, remember sine is y over r. If the unit is 1 unit up, then r has to be 1, because r is the distance from there. Or you could say, okay, 0 squared plus 1 squared equals r squared. So 0 is plus 1 is 1. So r squared is 1. So r equals 1. So if you pick the unit 1 unit up or 1 unit over, r is really easy. It has to be 1 unit. So sine of 90 is y, which is 1, over r, which is 1. Cosine of 90 would be x over r. Gotta have those memorized, my peeps. So x would be 0 over 1, which is 0. Tangent is y over x, so it'd be 1 over 0. Uh-oh, I'm having flashbacks. If 0's on the bottom, it's undefined. That is true all the time. So you actually can have trig functions that are undefined. Now, sine and cosine are always defined. It's the other four that can be undefined. Now, we know cosecant is the reciprocal of sine, so flip sine, there we go. Cosine is 0, so secant is the reciprocal, which would be undefined. And tangent, this is 1 divided by 0, so flip it to get cotangent, and that would be 0. Well, I'm going to do 2 videos today, 2 parts, just so it's 2 small things that make life easier for me. So I'll see you in part 2.